Now,
Just
what I want all of you to do is, before I even go to the objective, go to the trivia quiz. Alright? Go to the trivia quiz on page 3. Alright? Just do the 4 questions. Then I'll have a quick chat with you about what binomial distribution is. Go to the trivia quiz.
Oh, Germany. Oh.
Axis, bro. No, it's Japan. It's Japan. It's Japan. The Axis power is not Japan.
I'm keeping my mouth shut. Only 4 questions.
Is it dog? Sign up for it. Yeah, I got it.
It's trivia, and I don't know whether you know any of this. Probably not.
How can you be scared of doggies?
In what year did was it? How do you just know that?
Isn't it 85?
He wrote 89.
Alright. It's just a quick one. It doesn't matter whether you know or not. Guess if you don't know. Alright? I want you to guess. There's only one answer for everyone.
No, 1989.
No.
Page 3.
It said 1990. What it said?
Alright? Now, so
89.
you've got 4 questions.
4 questions with 4
4
possible.
trivia quiz, 4 questions. You probably have no idea any of the answer.
What? I knew the first one.
If you know a few, pretend you don't know. Alright? So pretend you don't know, because I'm going to use this to talk about binomial distribution. What is a binomial distribution? How do we derive the formula? And let's evaluate some probabilities. Alright? So, now, if you go into a test or a quiz or whatever,
Location.
you don't know anything.
What's your highest? Of course, you go to school.
You have no idea. You have no idea what the answer is. So what can you do?
You guess.
You guess. Correct. You guess.
Educated guess.
So I will review the answer now for this 4 question.
Yeah,
Right.
100%.
I don't know whether you guess it right or wrong or whatever.
Alright.
100%.
So
100%.
It's
give me
proportional to my
a guess.
English mark.
Now, out of this 4 question, alright, if you could think about how are you going to work out the probability that you answer all questions correctly. Now, assuming that you have no knowledge, those are the trivia quiz. And how are you going to answer all,
4 options.
what is the probability that you answer all questions correctly?
For each.
And what is the
What are the
probability
four
that you
times
answer half correctly and half incorrectly? Now,
It's 1 on 4 to the power of 4.
the focus question is now how
Yeah, that's what I said.
You just said 1 on 4.
No, 1 on 4 times, 1 on 4
the
times.
problems
That is what I
relate
said.
to binomial distributed random variable. How do you relate
what I
each one
said.
of these?
It's not what I said, but it's what I thought.
To the
Okay.
not binomial, the
It's not
Bernoulli.
right, but it's not right, but yeah.
To the Bernoulli distributed random variable. So if you look at each question, there's only one correct and the rest are all incorrect, correct? Yeah?
Yeah.
Yes.
One correct, the rest are all incorrect. So, what does Bernoulli distribution?
Only 2
Implies.
options.
Only 2 options.
Oh, yeah.
Correct or wrong. Right? So here, each question. Question 1, probability of you guessing it correct is 1 over 4.
That's not Bernoulli.
Incorrect is
Yes, it is.
3 over 4.
It is.
It's
Same
still
with
one or
question
the
2,
other.
same with question 3, same with question 4, correct?
Yeah, but that's white.
Only one correct.
Related
There's
to-
only one correct answer. There's no 2 or 3 correct answer.
can
There's
drive.
only one.
I can try.
Yeah.
So now, every single question here, you don't know, but you're guessing the answer. Whether it's right or wrong, you don't know. So you're taking a chance. Alright? Now, so here, if we have the discrete random variable that gives you the answer correct, i.e. success is 1, think about the Bernoulli distribution. So we know that each question, probability of x equals to x, which is success 1, is 0.25 or 1/4. Failure, you did not pick the right answer, is 0.75. Correct?
Yeah.
And we've got 4 questions in this case. So how are you going to use that Bernoulli to sort out the probability that you answer all correct? You answer all questions correctly or incorrectly or half correct and half incorrect?
1 and 4.
No. You can always use a tree diagram.
Oh.
Yeah? So you can work out something like
that?
4 correct, and then you've got 3 correct and 1 wrong, and so on and so forth. Yeah? You can do it that way if you want to. However, if I do it that way, I can actually write this all down.
So the last one should be 0.75 times 0, right?
Oh yeah, sorry, that's 0.75 to the power of 0. Thank you. That's my copy and paste job, and I did not change that. That is the power of 0, thank you. Alright.
Which one?
So,
correct or wrong?
if you
S
think
is
about
right. Is it S
that.
is right?
Now,
Success and fail.
success. There's no success here, so 0.25 to the power of 0. 0.75 to the power of 4. Now, each one is independent. Correct?
Do the Bernoulli
Yeah.
So
distribution.
therefore, it's multiplication. That's only 1. The second one, you've got success, 1 success, 3 failure. 0.25 times 0.75 times 0.75, 0.75.
Yeah.
In this case, you got 4 of them. So therefore, it's 4 times that. Right? 6 of them, half correct, half wrong. 0.25 twice. Because
6, 4, 1.
you could pick question 1 correct, question 2 correct. The outcome of question 2 is independent from 1. 3 is independent from 2 or 1. So you can multiply,
4.
and then 6 of them, 4 of them, and then 1 of them. Now,
Because you do 4, choose 1.
what does
Yeah,
that?
1.
Yeah.
1, 4, 6, 4, 1, what is that?
It's the row 4 of Pascal triangle.
Yes, the Pascal triangle is your binomial
True.
coefficient, correct?
It's true, it's true.
So you can write it as 4C1, or for me, when typing it, it's a lot easier to use the big bracket, so I do it this way. Alright? 4 choose 0. Or 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. Agree? Now, next bit. How are we going to link that as a binomial distribution? Oh, sorry. Let's answer the question first. So, with the probability of answering all questions correct, so I've got 4 choose 4, all correct, 0.25 to the power of 4 times 0.75 to the power of 0. Because that's, every single question is correct. So it's 0.25 times 0.25 times 0.25.
Bin. This is the bin.
Alright, this time, if everything is incorrect, 0.75 times 0.75, 4 times. So it's 0.75 to the power of 4. The next one, 2 correct. I don't know which 2 questions are correct. Could be 1 and 3, could be 2 and 4, could be 1 and 4, could be whatever. So I'm going to choose out of that 2 questions correct. So I've got to choose out of 4 questions, I'm going to choose 2 that's correct. And the probability of 2 correct is square, 0.25 square and 0.75 square. Alright? So I've got to choose 2 questions out of 4. That will give me 6 combination. Agree?
Yeah.
So that will give me 6 combination. Therefore, I need to have 4 choose 2 correct, 6 combination, and then your probability. And it should be 0.21039. I don't know what my typing is. I gotta check that.
200%.
Not
2 million.
That's impossible. Alright, it's my fault.
It's over 2.
So,
It's whatever one.
let's talk about binomial distribution. So, if the random discrete variable x are formed by a series of n identical and independent distributed Bernoulli trials. So you can see that 4 questions, they're all identical, correct? You've got 1 answer only. And independent because if you get question 1 wrong, it doesn't affect question 2. It doesn't affect question 3 or it doesn't affect question 4. So it's all independent. Each with a probability of itself P. you've got one answer correct, 0.25, and the failure of 1 minus p. Remember, 1 minus p can be written as q as well, all right? And x represents the number of successes out of the trial. So, it could be 2 correct answers, or 3 correct answers, or 1 or 0. Then x is binomially distributed random variables. And we can represent this as x is binomially distributed with n and p, where n is the number of identical and random distributed trials, and p is the probability of success for the single Bernoulli trial.
So one trial is like one question for that example.
Yep. One trial is one question.
Yeah.
All right. You have 4 questions, 1 trial. Okay, no, it's 1 success or 2 success, or 3 success. You're answering 4 questions, so you've got 4 questions, and you're picking 2 correct, or 3 correct, or 1 correct. Right?
So it's like how many you get correct.
Yeah. So the focus of the distribution is how many successes occur, and hence you need to consider the number of ways the successes could have occurred. All right, that's important. So you're talking about how many successes. That's it. So out of 4, you may have 2 correct, you may have 3 correct, you may have 1 correct. Now, the probability mass function. The probability mass function of binomially distributed discrete random variable x, which is represented by, which is a binomial distribution with n trials and probability of success of p. X is the number of success, can be defined as probability of x equals to small x, and choose x. Success, so this number is always related to the success. Alright, number of success is p to the power of x, and number of, that's failure, 1 minus p and minus x. For x equals to 0, 1, 2, 3, 4 until n. Now I'm going to summarize the condition for this to occur. Alright? So, the following 5 conditions must be satisfied for a discrete random variable x to be binomially distributed. 1. There's always fixed number of trials. For example, there are 4 questions only. There's not 5, there's not 6. You're not doing 5 questions, 3 questions out of 4 or 2 questions out of 4. You're always, it's fixed to 4 questions. So each trial involves either success or failure. 1 is success, 0 is failure. Alright? And all trials are independent. So the 4 questions, like I say, the outcome of question 1 does not affect outcome of question 2, does not affect outcome of question 3. So it's independent. And the probability of success P is the same as each trial. So if the question, one of the question has 2 answers, then you cannot be binomial distribution. So we are only thinking about everything, the probability of success has to be the same in each trial. So question 1, question 2, question 3, question 4, P is 0.25 for success. And the variable is the total number of success in the n trial. Alright? So you need to think about, always remember, state the value of the parameters n and p in any binomial distribution question. Especially if you are asked to define or describe the distribution. So just write in the form of x with a squiggly line, binomial distribution, n and p. Alright? So that's important, the 5 conditions must always be satisfied. Now, let's have a look at example 1. Which one of the random variable described below would follow binomial distribution? For those that do, state the distribution's parameters, or the PMF. Oh, sorry, not parameters, which is x, squiggly line, binomial, whatever, n and p. Alright? the number of faulty items, T, produced in a factory per day. If the probability of each item being faulty is 0.01, and there are 10,000 items produced every day.
Yes.
Now, what sort of assumption that you have to make in this situation if you think that it is binomial? What sort of assumption?
That
You've got to assume in this, yes?
that it's only faulty or not faulty.
Yeah, only faulty or not faulty, that's one. What are the things that you need to think about?
Independent.
Independent. So, the faulty, the faulty items, if the machine produces a faulty item, it does not affect the production of the second item. Alright? So here, therefore, we can say that it's binomial. Fixed number, 10,000 items, which is 10,000 trials, 10,000 items, two possible results, faulty and not faulty. A constant probability of success, faulty is 0.1.
So you put in the percentage.
Not faulty is 1, take away 0.01. And T is the total number of faulty items. As long as the faulty items occurs independently, T is that. That's the description. Now, the number of red cards drawn from a standard shuffled 52 card pack in 10 picks. Not replacing the card each time. Is this binomial?
No,
No. Why?
because the probability changes.
Thank you. It's not independent because you are, the card is not replaced. Thank you. That's not independent. Alright? C. The number of red cards drawn from a standard shuffle 52 pack in 10 picks. Replacing the card at each time. Yes, because it's a fixed number of trial, 10, and possible results either red or black or red or not red. Constant probability of success because the cards are replaced, and R is the number of red cards drawn.
So how is 0.5?
Because
Red.
there's only 26 red and 26.
Oh yeah, true.
Don't think about the joker. We don't include the joker in this situation.
Yeah.
What about the number of times T? I have to toss a coin before I get ahead.
No.
Not fixed.
No, since the number of trials is not fixed. Thank you. E, the number of left-handed people. L, in a sample of 500 randomly chosen people, if the fraction of left-handed people in the population as a whole is 0.13. So you're using your relative frequency in this case?
Yeah. So it's yes then.
Yes, it is. Because there's a relative frequency now, you're allowed to use your relative frequency. And it is. So it's 500, 0.13. Experimental.
So like if you have 200 people that have red hair out of 500 people, probability of them being
Alright.
red is 200 to 500.
So you do know what it means by
Feel targeted.
binomial distribution now. Let's have a look at some example, some calculation example. So if you're given that X, we've got 5 trials and the probability is 50% of success, can you determine the following probabilities?
Oh shit, I forgot the formula.
5 on 2, and then P of
So
X.
5 select 2.
Probability
The
of
first one is
success
5C2, correct? Because X is 2. And you've got a set number of allowed is 5. So it's 5C2. Now this one, relatively straightforward because the probability is half. Success is half and the probability of failure is half as well. So
N minus
makes life a little bit easier.
5.
Potentially in Calc 3 question,
I don't know.
but I don't know. I mean, if it's Calc 3, you will not use 0.5 to calculate, you will use half. Alright? So you need to remember, use this. And since this is given, you know that N is 5 and P is 0.5. Alright? So if x is 2,
Yeah, it's just no. Well, because I'm just taking.
you know
the
that
case
you
where
can
x is
use
0.
Oh, so this is this.
NC2.
This is this.
Without
This is-
calculator,
this
I
is-
work
is
with
that-
fraction.
This is B.
1
Yeah,
over
yeah.
2
No, no.
square or cube is just a little bit easier in my opinion than 0.5 square or cube. Alright? I use fraction. It's okay if you change it to fraction. So especially if I want
So,
well, this should be exact.
is
yeah.
this formula on the formula sheet?
I think so.
Oh, please don't even remember it.
Let me check. Yes, it is. It is on the formula sheet.
Oh, perfect.
All right. It is on the formula sheet. So
Can you like do some?
No.
work out 5C2. You can use your Pascal triangle if you want to.
He's doing it. So this would be calc-assumed, right?
And no, it may not be
Oh.
because
Yeah, I know it's easy.
you,
It's not that bad.
you should
but
know
like,
your whatever you should
I
know
know
your
my
Pascal
common
triangle, your 5C2.
I love common
So
types.
therefore, it's 10 over 32, or if you want to simplify it, is 5 over 16.
I can't be bothered.
Now, if it is greater than 1, which means is,
It's everything but 0.
that's correct, thank you, 1 minus p equals to 0, everything but 0. So, therefore, you can work out, or you can do probability of x equals to 1 plus probability of x equals to 2 plus probability of x equals to 3 plus probability of x equals to 4. You can do that as well if you want to. Alright?
One, two, three, four.
Makes life easier if you use a complementary. And therefore, it is 31 over 32.
3 times 2 times 1. Just
Alright.
go down, down, down. Yeah.
Happy with example 2? Let's go to example 3, please.
Oh, no.
Can you go back?
Now, this is a fair spinner,
It's like maximum.
He doesn't need it. He
and this is spun 7 times.
Oh, for the last one? 31 over 32.
He
So-
doesn't need it. He tried.
A and B, they are related. They're talking about
2 5s are obtained.
2 5s are obtained. One is 2 5s, one is 3 5s. C is slightly different. So you can see that the binomial distribution for A and B should be the same, and B is slightly different. Correct?
Not that hard.
So doing that, if I let X be the event of spinning a 5. So a 5, the probability of success is 1 over 5. Because there are 5
This is P x equals
5 segments there.
Oh,
So it's 1 over 5, they are all equal, it's fair, 1 over
I
5.
didn't do it because he did it.
So, therefore, I write down
10 over 32.
the distribution,
10 over 32.
7 trials,
Can you get a 10?
and the probability of success is 1 over
That's
5.
just what it was on the board.
Alright.
I didn't really do it.
Now, 2 5s are obtained. So out of the 7, I want 2 5s. So 7C2. This one is calculated. You have to be able to use your calculator. So it's 0.2753.
Yep.
Got it? Agree?
Yep.
Make sure that you know how to use your calculator, and B should follow the same thing. I should have done A1 and 2 because in that case I don't have to rewrite my distribution, but I did rewrite the distribution.
This one or?
And you should be able to work out.
Is that the last one?
Speed.
No, let's see.
7 choose 3,
Why is it 7?
and
Oh,
it's
7
0.1147. Next one,
Wait.
if you think about the next one, 4 numbers less than 3 are obtained. So less than 3, you've got this bit and this bit here. Correct? So the less than 3, the success is 2 over 5, and the failure is 3 over 5, correct?
Be that line.
So you're going to rewrite your distribution. So your distribution now is therefore,
You have to state the distribution every time. So.
yeah, you have to, you are supposed to state the distribution every time. Definitely. Remember I said in the previous slide, always state your distribution. So, and define x, or you can define something else. You don't have to use x. But now I'm letting x as a event of spinning 1 or 2. So because of that, you know the success is now 2 over 5. Alright? No longer 1 over 5. So I spin either 1. This is 1 over 5, that's 1 over 5, so therefore it's 2 over 5. You can add them together in this case. So therefore, you can work out 7C4, and that's your probability. See, in one question, you could have 2 different binomial distribution. Yeah? You got to think about what the success is. That's important. The success is the important one. Because when we write the distribution of x is binomial and is the number of trials, and P is the probability of success. Alright, that's so important to know that it's related to success. Alright, I think this is the last example. A biased coin is tossed 4 times. Alright, so I know that n is 4. The probability of a tail occurring on any toss is P. We don't know what P is, but we do know that the probability of success is P. N is 4 and P is P. So always write down N is number of tails, and therefore X is in binomial distributed, and N is 4, and P, we don't know, P is P. Alright? In terms of P, you should be able to work out what that is. X equals to 4, 4C4. Success P to the power of 4, 1 take away P to the power of 0. So therefore it's P to the power of 4. And 3 tails. See, part A leads to B. So you can work out part B in terms of P. Now, look at B. B it's possible because we've stated that this is actually a biased coin. Alright? A biased coin, P is not half. You need to work out what P is. So here, you were told that probability of 4 tails is equal to probability of 3 tails. So what are you going to do? Equate this, P to the power of 4, and 4P to the power of 3 minus 4P to the power of 4. Alright, you've got to equate that. Now, do that. Of course, you know how to solve. Alright? Alright, now, can I accept P equals to 0?
No.
Why? In this context, why can't I accept P is equals to 0? Yes, it is not impossible because you're tossing the coin. When you're tossing the coin, you either get head or tail, right?
There's no success.
Sorry? It's a biased coin.
Yeah, but then if it's 0, there is no success
coin.
or fail.
It's
If
success
it's
or
0,
fail.
there's no success or fail.
So you cannot have 0. It has to be 4 over 5. Alright? It's not possible. P reject P equals to 0 because it's not possible in this context. Tossing a coin. So therefore, P has to be 4 over 5. So it's biased towards the tail. 4 times out of 5, you get a tail. Alright?
It's hard, bro.
It's not that bad.
Now, I'm going to stop here. I will do a bit more on Wednesday.
That's probably.
Please bring a calculator on Wednesday. Class rep.